In this video, we'll be discussing problems based on optimization. So this is a typical application of your second derivative test. So we'll be using second derivative test to solve such problems. You can also use first derivative test to solve these kind of problems, but second derivative test is more relatively easier. So let's have a look at the question. So the question says a wire of length 2 units is cut into two parts to form a square and a circle respectively, right? So let me just draw a wire. So this has been reformed to a square plus a circle, right? So usually when you solve these kind of problems, you'll be always given something that has to be optimized. So what do we exactly mean by optimization is that we should either minimize something or you should either maximize something. For example, in the cases of business or when it comes to profit or loss, we always like to maximize the profit and we like to minimize the loss. And in terms of area, sometimes we like to have the maximum area possible, or sometimes we like to have the maximum result or the maximum volume that could be obtained from a particular case. So these kind of problems naturally fall under optimization. So first you should always look after the word maximize or minimize, the word which connects to optimization. So here we are given with the word minimum, right? So what has to be minimum? The area has to be minimum. So the area function is the one that has to be optimized, and they have given sum of area of square and circle. So let me just write the function to be your So let me just write the function, the one which has to be optimized. So let me call for the function which has to be optimized. So basically we'll have to minimize over here, minimize the area function. And what do we mean by area function? It is the area of the square, so it is x square, and circle's area, which is pi r square. So this is practically a function which is in two variables, because here you are having x as well as here you are having r. So now the problem is to convert this function which is in two variable as a single variable function. And how will I do it? So let me read the question once again from the beginning. It says the wire is cut into two parts to form a circle and a square. So we are going to use the hint. So they are saying that the length of the wire is of 2 units. So the perimeter of this particular wire equals to the sum of the perimeter of this square and the circumference of this particular circle, right? So 4x plus 2 pi r would give me 2. So this is what I usually call to be your helping equation. This is something I usually name it, your helping equation, meaning this equation is going to help to change this function to one variable function. So how will I do it? Let me just divide it by 2. So I will be getting 2x plus pi r is equal to 1. So 2x is equal to 1 minus pi r, x is equal to 1 minus pi r divided by 2. Now I can substitute this x equals 1 minus pi r divided by 2 in your area function. So using 1, I will be getting my area function to be 1 minus pi r by 2 the whole square plus pi r square. Now this whole function has now got converted to your area function, which is in terms of r. Now the whole function is in terms of r. So let me expand it. So 1 by 4 a square plus b square minus 2ab plus pi r square. So if I multiply 1 by 4 inside, pi square r square by 4 minus 2 pi r divided by 4 plus pi r square. So now let me differentiate this function. So it becomes 0 plus pi square by 4 times 2r minus pi by 2 times 1 plus 2 pi r would be the first derivative of this area function. Alright. So let me also simplify it. So we are going to get pi square r by 2 minus pi by 2 plus 2 pi r is your first derivative of my area function. So we are going to find the stationary points, and to find the stationary points I am going to substitute a dash of r equals 0. So pi square r by 2 minus pi by 2 plus 2 pi r would be 0. So pi square r by 2 plus 2 pi r equals pi by 2. I can probably cancel out the pi's and I can remove r outside, which should give me pi by 2 plus 2 is equal to 1 by 2, and now r times pi plus 4 by 2 is equal to 1 by 2. R times pi by 4 by 2 is equal to 1 by 2. 2 gets cancelled. Now r would be 1 upon pi plus 4. R would be 1 upon pi plus 4. So this is your stationary point. And at your stationary point, you can either have your local maximum point or your local minimum point. To confirm that, we'll be using a second derivative test. So let me find the second derivative with the help of the first derivative. Your first derivative is present over here. And if I start to differentiate your first derivative, I'll be getting pi square by 2 times 1 minus 0 plus 2 pi times 1. You'll be getting pi square by 2 plus 2 pi. So no matter what r value you substitute, this function is always going to be positive. So I can write it as, since it is positive, the area is always going to be minimum. So this is your second derivative test result. So your area is minimum at exactly r is equal to 1 by pi plus 4. So let me find the x. X is given by 1 minus pi times r, the whole divided by 2. So pi plus 4 minus pi divided by pi plus 4 divided by 2, plus pi minus pi cancels out each other, and I can write it as 2 upon pi plus 4, which is your x. So since I've written x as 2 by pi plus 4, it is technically 2 times of 1 by pi plus 4, and 1 by pi plus 4 is r, right? So it is 2 times of r. So x is equal to 2r is the solution for this particular question. So this is how you'll be solving a problem on optimization using your second derivative test. So the final answer is then x is equal to 2r. Hope you learned something new from this video. Thank you.